So let's take a look at our VEP results. And I've done this filter by missense. I'm going to get rid of that. And actually the filter that I want to put in instead is going to be, I'm going to start with an allele frequency filter. So we want things that are really low. So I'm going to go allele frequency is less than, so all of these filters in the list match up to the headers. So if you're not sure what they mean, find them on the headers and hover over them to see what it is. So I'm going to say allele frequency less than 0.05. I'm going to add this filter. So I've got much fewer variants on my list now. It's really shrunk down how many I've got, but I've still got more than I can reasonably go through. So I think I am going to try and filter by consequence. And before I filter by consequence, I'm actually going to try impact. Impact allows you to take into account numerous different consequences. So if I go with impact is high, this will give me all the loss of function variants, so things like stop gained. In this case, there's nothing that's impact high, so I'm going to get rid of that, and I'm going to switch it out and go with consequence is missense variant. And if I add this, it should shrink it down. So now what have I got? I've got variants in COQ6, in LZTR1 and in NF2. So I'm going to take a look at my list, and because this is quite a fake VCF file, it turns out that all of those genes are actually on this list. So all of the low frequency or not observed variants that we found are actually ones that have been associated with neurofibromatosis. So now I'm going to take a look at some of the other columns listed here and see what more I can get out of it. So I've actually only got 4 variants here. So I've got 2 in COX6. So you can see, no, I've got 1 in COX6. I've got 1 in LZTR, and I've got 1 in NF2. It's just that it's overlapping multiple transcripts. Oh no, I have got 2. Sorry, they look really similar because they're exactly 20 bases apart. So I've got 1 and then a second one in COX6. So I'm going to scroll across and see if there's anything else that I can use to filter these down. So my SIFT and polyphen scores, I could potentially use these. So this first one, that's these top 3, doesn't particularly look that convincing. The second one does have some that are listed as deleterious. And our third one has got some that listed as deleterious. This bottom one doesn't seem to be having any negative effect at all. So as I look at these allele frequencies, I'm still not convinced by the fact that these could be causing a disorder like neurofibromatosis, because these are all quite high frequency still. If I saw this frequently, sort of 1% of individuals here is actually quite high. And I would really expect this to have been not observed at all in the 1,000 genomes, because I know that none of them had neurofibromatosis. So I'm actually going to get rid of this filter. I'm going to switch it out for existing variant is not defined, and I'm going to see what I find instead. So now we have a variant in MARCB1. And if I scroll across, you can see that in only 1 transcript it's been listed as deleterious. But I have no allele frequencies. This is a completely novel variant. It's never been observed before, so there's nothing like clinical significance. And actually, even though I've got some variants which are found in neurofibromatosis genes, this is more likely to be the one I would go for. And if I just check this list, this gene is on this list as well. So this would probably be the one that I would take forward to further study. Now I'm actually going to cheat a wee bit, because I've just shown you how you can do it all very manually and investigate what a variant might do. And it's really important that you understand what's involved in variant prioritization. But Ensemble do actually have a cheat, and it's what we call the Gtp plugin. So I'm just going to hop briefly back into my presentation and talk about the Gtp plugin. So the Gtp plugin is a tool that we've created for clinical analysis of variants, because it does a bunch of that filtering I just did for you. So one of the things it does is filters by a list of genes. So there are lists of publicly available lists available, which give you lists of genes that have been linked to clinical phenotypes. So it filters out all of the variants which are not found in these genes. It filters out those that to give you only those that have a severe consequence that are likely to affect protein function. So there's high impact variant and missense. And it also filters to only include things that are novel or have a low frequency. And then it also looks at the allelic requirement of the gene. So if we go back to our VCF, which has got the genotypes at each particular variant, so you can have 1, 0, 1, 1 or 0, 0. This looks at what's known about these genes. So if it's known that a particular gene requires a homozygote for mutation, then the variant will match and look for both copies having at least one variant which passes all the filters. If we're looking at a dominant or a haploinsufficient trait, anything that you only need one copy of the gene, then it only looks in one copy for the variant. There's a link here that allows you to get the information about it and to learn more. I'm just going to show you these files, these Gtp plugin files. There's quite a lot of information. This is the publicly available Decipher file, and you can also get one from Panel App from Genomics England. So the main thing it's looking at is the gene symbol and the allelic requirement. All of the rest of the stuff the VEP Gtp plugin ignores. These publicly available lists, the Decipher Project and the Panel App. So Panel App was produced by Genomics England, and Decipher comes from the DDD project, which again focused mainly on European populations and identifying the variants in rare disease. So there is no kind of real African specific Gtp plugin file, but if somebody wanted to make one, that would be a really cool project. And you can make them if you put the right information in. So I'm actually going to show you how you can run this in the command line. So I've opened up a command line here. This is the VEP command that's using this Gtp plugin. And if I just go into this, it's going to run the VEP for me using the command line version, and it's going to run that Gtp plugin as well. The installation for this is quite involved, so I'm not covering it in today's course, but if you want to look into it, please do look at the documentation online. It's doing lots of thinking and messing around at the moment and producing data for me, but very shortly it will tell me that it's done because it is quite a small VCF file. Okay, so that's it done. It's ready for me to show another one. Now I've actually pre-done this and put the file up for you. So it gives you this HTML output that looks like this, and it shows you what the thresholds are that it puts in, and we can see that this variant that I found through the manual variant prioritization has come up through this method as well. So this is obviously a much quicker, once you've got it installed, this is a much quicker method of identifying variants that are likely to be disease causing. So now you've got an exercise to do that where you can go through your VEP results from the previous exercise and identify which variants you think might be causing a rare disease.